Alright, here's a lesson on Incline Planes number 2, where we now have two objects in the system. We still have an incline at a specified angle. We have one object here, and we understand how to do a free body diagram of that. We've got Fg, we've got normal force, and of course we break this up into Fgy and Fgx. And of course the angle in here, this angle, is the same as that angle. So far, everything is the same. However, now what we have is that this object is connected by a string, and it goes over a pulley, and then down here is a second object. So just remember that there is a pulley right in here. I won't draw it, but there's a pulley. And so this object now also has a force pulling down like this. And that's the force of gravity. So now we have another force added onto our situation. Before, all we had were these, and now we've got this one. And when we looked at this, we broke up Fg into the components of Fgy and Fgx. And it looks like that we should do the same here, because this one is pointing in the same direction as this one. The thing is, the beauty of a pulley is that it changes the direction of a force, but does not change the angle. So whatever this force here is the same force here pulling in this way. So I could draw this force up over here, and I'll draw it as a dotted line because it's not actually there, but we can pretend that it's there. So all I've done is I've said that these two here are the same. If I look at it this way, now this force happens to be parallel with this, and Fgx is also parallel to this. So if I view these forces in here as being the forces on my system, then now I can very easily take these two to being in the exact opposite directions. I don't have to do any weird geometry, trigonometry, triangle work with this guy. And in fact, I can then pretend that this one doesn't exist. Let's see what my eraser. No, can't erase that. Okay. Now, the only other issue that we've got is that we have two Fg's labeled. And so we'll try to specify them that this is Fg1 and this is Fg2. Meaning that this is mass 1 and a mass 2. Now keep in mind, this is not our system. If this is strong enough to actually pull down and this comes up the incline, then both of these are going to accelerate, and they have to accelerate at the same rate unless this rope or string compresses or contracts. So this whole thing is actually now our system. This is our system. So this mass and this mass are going to be accelerating. This happens to be our total mass. When we look at this now, we understand that Fn and Fgy cancel out. And so the only forces that are left in our system are Fgx and Fg2. Sorry, I forgot to put a 2 in that one. So when I come to my equation, hold on. Let's see if I can remember how to do this. F net, and I'm just going to move this over here. F net equals F1 plus 2, so on and so forth. Now all I've got now all I've got is that I can quickly this again, F net equals, and now in this case we have FGX and we have FG2. The only thing we need to remember, and you notice I haven't put in a symbol here yet, is that these two are in opposite directions. FGX is going down the incline, FG2 is going up the incline, so they're in opposite directions. So one needs to be positive and one needs to be negative. So that means that I need to decide which one of these two is going to be positive or negative. Typically we've done down the incline as positive, so let's make FG2 negative, so I'll put a negative in there. There we go. So this now becomes our F net situation for this kind of problem. Now what I can do is if I actually happen to have these two masses, I can figure out what FGX is, I can figure out what FG2 is, and I can actually figure out what the net force is. And if I know the net force and the total mass, the total of these two put it together, then I can figure out the acceleration. So let's see if we can do that as an example. Alright, so here I've got a setup now where I've got mass 1 and mass 2 on an incline. I've specified that the acceleration is 0, so these two are either moving at a constant speed or they're not moving at all. Typically we think of it as not moving at all. And what I'm going to do is I'm going to specify the angle, I'm going to specify what this mass is, and what we need to do is to figure out what this mass needs to be in order for this situation to work. Because remember, if this one is stronger, if this force here of FG2 is stronger, then this is going to accelerate down. If FGX from here is stronger, then this is going to accelerate this way. We've said that this direction is positive and this direction is negative. So let's go ahead and draw in our forces. FG1, FGX, FN, and FG2. So now when we start taking a look at the mathematics, I want to figure out what this all is. Okay, so we start off with our two equations. We've got F net equals MA. Move that over here. And we've got F net equals FGX minus FG2. Do that more over here. Okay, so now let's first of all figure out what our net force needs to be here, because hopefully this is relatively obvious. In this case, F net will equal whatever the mass is. I still haven't specified the mass. And the acceleration is 0. So where's my brackets? Just a second here. There we are. 0. Okay. So then hopefully we can see that F net is going to be 0. We already can see that. So I'll just quickly put that in. That F net equals 0. Okay. So in this case, it didn't even matter what the mass is, because whatever the mass is times 0, that is 0. So we already know that this is 0. All right, let me specify some values now. We're going to say that the mass here is, let's say, 5 kilograms. And that the angle in here, let's say, is 30 degrees. Let me put those in blue. Yeah, okay, well, I'll leave it like that. So if this is 30 degrees, then that means that this is 30 degrees. Now ultimately, if we're looking for this mass, I don't see mass 2 listed anywhere in here. However, I know that this is already 0. FGX comes from the first mass, so that has nothing to do with this one. But FG2 comes from this mass. So really what I'm looking for is whatever this value is, right here. So that means I need to know what FNet is and FGX in order to figure out FG2. And once I know that, then I can use mass times gravity to figure out what the mass will be from here. This one I already know is 0, so now I need to figure out what this is. If you remember from the previous lesson, this here is just the mass and gravity of this multiplied by the sine of the angle. So I'm going to do a substitution here. So I'm going to do a brand new equation, and I'm just going to start it and then move it so you can see it. So I'll do this. My FNet. Oops. Equals. So what I've done is I will do, let me try something here just to help us out. Mass, just so that we don't get numbers mixed up here. Mass 1. It looks a little weird, I understand that, but that's mass 1 times gravity times the sine, in this case, of 30 degrees. Okay? And then we have minus FG2. FG2. So all I did is a substitution of FGX to M1G sine theta. And in this case, the theta is 30 degrees. This is already 0, so now let me plug in my numbers here. Alright, let's see if I can... Oh, okay. Figured out a little shortcut here instead of retyping it. So now I'm going to go in here. Okay, so... let's just back this all up. Equals... Mass is 5, so let me put in brackets here. 5. And gravity, of course, is 9.8. There we go. And then now I can figure this all out. Do all the math. Let's see here. There we go. So then I'm going to use my calculator. 5 times 9.8 times the sine of 30 gives us 24.5. 24.5. And FNet is 0, so we're going to put in 0 for that. Oops. Not a bunch of equal signs. 0. So then hopefully you can see that FG2 is just going to equal 24.5, and it's just in the opposite direction. We understand that. Okay. So then I can rearrange this. And I can get FG2 equals 24.5. So now that I know that FG2 is 24.5, now I can figure out what the mass is because I know that this is mg. So let me do a new equation. FG2 equals mg plug those values in. I have 24.5 equals m times 9.8. And so I'm just going to divide. So I will get m equals, oops, right? 24.5 divided by 9.8. And that gives us 2.5 kilograms. So then this is now our answer. It happens to be exactly half of 5. It just works out nicely in this situation, but that you can't assume that that's going to work out nicely. So we figured out what this is going to be, what this mass needs to be when the acceleration is 0. We could, of course, figure out the same kind of thing if both masses were given to us and then figure out the acceleration. So really what I'm doing here is I'm figuring out what FGX is. If I know the mass and gravity and the angle, I can figure that out. If I know the mass of the second one, I can figure that out over here. And then I can figure out what F net is, so I can figure out what that value is if I know those two. And then using F net equals MA, then I can figure out what the acceleration is because I know the F net, and the mass just happens to be the addition of these two together, the total mass. So we can also do that. That's a relatively simple extension. But let's try another problem that's a little more difficult. So I will try another example here. All right. Here now we have this mass 1 and mass 2. Let me just go ahead and put those in. I'm going to specify what mass 1 is. We're going to keep that at 5 kilograms. Okay. And I'm going to keep this at 30 degrees. So it's a similar kind of situation. But now what we can see is that this is actually going to accelerate this way at 2 meters per second squared, which means that this is going to be pulled up at 2 meters per second squared. And now what I want to do is I want to figure out what this mass over here is, what mass 2 is. Now hopefully we can understand that in the previous question, if this was at 2.5 kilograms, there was no acceleration. Now that there's an acceleration here of 2 going this way, hopefully we can understand that this has got to be less than 2.5 kilograms. We can already figure that out. This has got to be less weight, less mass than in the previous one in order for an acceleration of this way. So all we're going to do then is do similar kind of work, but you'll notice that some of the math gets a little more tricky. So we're going to start off with the math that we know again. Oh, let me do a free body diagram first. I'm just going to do this again. So FG1, that's FGY. We have FGX and FG2, and of course the normal force. And it's FGX and FG2 that we're interested in. Those are the only ones that are going to potentially cause an acceleration, and they're in opposite directions. Okay, so let's see if we can work with some of this again. So we've got F net equals MA, and we've got F net equals FGX1, FGX minus FG2. Now, one thing to keep in mind here is that the F net, this mass is the total mass. So I'm going to rewrite that one just a slightly different way. I understand that it's the total mass, but I want to rewrite it. Write it like this. Like this. Here we go. Mass total times the acceleration. And I understand mathematically that the total mass is m1 plus m2. Hopefully that's a pretty simple extension. So I'm going to do some substitution work in here now right away to help us figure this out. All right. So I understand that F net is the total mass times the acceleration, so I'm going to write that in right away. So I'm going to put in mass total acceleration, and for FGX, I know that that is mass 1 times gravity times the sine of whatever angle we've got and I also know, I'm going to do another substitution here, that FG2 is here we are, is mass 2 times gravity. So I've taken F net and substituted in this mass total acceleration that comes from here. FGX, I've done m1 g sine theta, we learned that before. And FG2 is just mass 2 times gravity, so I did that substitution here. Now remember in this question, ultimately what we want to do is to figure out this. We see it right here, actually. So we're actually on our way here. I know gravity, I know the angle, I know mass 1, I know the acceleration, but I don't know the total mass. So I'm going to do one more substitution right here. I understand that the total mass is really just mass 1 plus plus mass 2. Close bracket. Now all of a sudden when I do this, it looks a little complicated, but look, I have mass 2. It happens to be in 2 locations, but nothing's squared, so I don't have a quadratic. But I have mass 1, I have acceleration, I have mass 1, I have gravity, I have the angle, I have gravity. It means I've got everything I need in here in order to figure out M2. So now I'm just going to plug in my numbers and chug it through. So let's see if we can plug and chug this through. Oh yeah, here we go. Mass 1 is a value of 5. Mass 2, I don't know. Acceleration has a value of 2. Now, the only thing I have to be careful of is that 2 is going down the incline, and we said that that's positive. So that's a positive 2. If the acceleration was up the incline, I'd have to put in a negative 2 there. So just be careful with that. Okay, and then I can put in all of this. I have 5 times 9.8. And I have a sine of 30 degrees. And mass times 9.8. All right, and I think my talking just caused a gentleman to move out of the way here at the airport, but oh well, his loss. He's not learning physics. Okay. All right, this math I can do in here. This math I can do, but what to do here? Remember, this is FOIL. 2 times 5 and 2 times M2. So let me write out a brand new situation. Oops, that's not what I want. I want to do this. Sorry. Alright, so we're going to do the math that we can. We're in here. We'll have 2 times 5 to give us 10. And we'll have 2 M2s. Oop, I need to make that more clear, sorry. Let me put that in brackets. Oh, it's a plus sign in there, that's why. 2 plus 2M2. So it's really, I've got 2 of them. And then 5 times 9.8 times sine of 30 gives us 24.5. And this, of course, gives us 9.8 M2. So now what I've got, this is like grade 9 algebra. I have so and so many M2s here, or so and so many M2s here, and so many M2s here. I just happen to have 2 of them, and I happen to have negative 9.8 of them over here. So I'm just going to collect like terms. I'm going to add 9.8 over to both sides, and I'm going to take the 10 and minus that to the other side. So this is what I'm going to get. We'll do a brand new equation here. Okay, 2 plus 9.8 gives us 11.8 M2. And that's going to equal, just move that over here, it'll be 24.5 minus 10. 24.5 minus 10. And now I'm just going to divide this. So I will get 24.5 minus 10, of course, is 14.5. So I'm going to get 14.5 divided by 11.8. And when I calculate that through, I get 1.23 kilograms. There we go. There's our answer, 1.23 kilograms. So you can see the substitution work that we did all the way through here. We understand that F net is MA, in this case it's just the total mass. FGX is M1G sine theta. FG2 is M2G. And then we just did another substitution that the total mass is these two added together. We needed to remember that the acceleration, whether it's positive or negative, we foiled this through. 2 times 5 gives us 10. 2 times M2 gives us 2 of those. And we have 9.8 of them here. We just then move stuff over, and then we did the rest of our math. So hopefully this helps you out if you were having some problems with this section. Okay, thanks. Bye.